Let's take a look at the factor theorem. A polynomial f of x has a factor of x minus k if and only if f of k equals 0. So what that means is if we use synthetic division and we get a 0 at the end, 0 as our remainder, then it is a factor of that polynomial. So determine whether x minus 2 is a factor of f of x equals x squared plus 2x minus 4. And we can do it in two ways. We can do it by direct substitution or by synthetic division. Now, when it's something small like x to the square, you could use a direct substitution. So what I mean is you take f of 2 and you plug it in. 2 squared plus 2 times 2 minus 4. We're just trying to check to see whether this is a factor or not. Is this a factor? So we should get 0 at the end. So 2 squared is 4, plus 2 times 2 is 4, minus 4. So 4 plus 4 is 8 minus 4. This is 4. So f of 2 is not a factor. So let's do f of negative 5. Determine whether x plus 5 is a factor of this polynomial. So let's check to see if anything is missing. 4, 3, 2. X to the first is missing. So we have a placeholder there. And so it says x plus 5 is a factor, and we would do that by synthetic division. So if it's x plus 5, we're going to put the negative 5 on the outside. So notice there's two ways that they represented this. So remember that the x plus 5, we put in the opposite, and then it tells us f of negative 5. So that should match here. Then we put in the coefficients, 3, 15, negative 1, 0, and 25. So drop down the 3. Multiply negative 15, this is 0. Negative 5 times 0 is 0. Negative 1 plus 0 is negative 1. Negative 5 times negative 1 is a positive 5. 0 plus 5 is 5. Negative 5 times 5 is a negative 25. And our remainder is 0. So when the remainder is 0, then x plus 5 is, yes, x plus 5 is a factor of the polynomial. Okay, so this is going to be really important later on because then this is one of our x-intercepts. That's what this is telling us. Well, one of the many things it's telling us. So try these. Determine whether each of these are a factor and then say yes or no. Try these out. Okay, if you tried this out, letter A is not a factor. You would have gotten 15. Letter B, yes, that's a factor. The remainder is 0. And then the last one, number 10, if you plugged it in or by doing synthetic division, you would have gotten that it would equal 40, which is not a factor. Again, it is a factor if it equals 0. So what we're going to do is use that factor theorem, and we're going to factor a polynomial. We're going to show that x plus 3 is a factor of f of x equals x to the fourth plus 3x cubed minus x minus 3. Then we're going to factor it completely. So this is no trick. We're going to show that this is a factor of this polynomial, then we factor it completely. So when it's in this form, we use the opposite, so negative 3. We're going to check it by synthetic division. Then we check to see if anything's missing. X to the fourth, x cubed, we're missing a 0x squared. X to the first is good, and negative 3. So 1, 3, 0, negative 1, and negative 3. So this should work. Okay, so there's no trick again. So drop down the 1. Negative 3 times 1 is negative 3. 3 minus 3 is 0. Negative 3 times 0 is 0. 0 plus 0 is 0. 0 times negative 3 is still 0. And then negative 1 plus 0 is negative 1. Negative 3 times negative 1 is a positive 3, and the remainder is 0. So x minus 3, remember, that is our x plus 3, so that is a factor. Then we need to write the rest of it completely. So remember, this is our remainder. This is x to the 0, x to the first, x squared, x cubed. So really important that you write these down. So we write down the x plus 3. That's what factored completely. Always write that one. Then we write what's left. We're left with x cubed minus 1. So we need to factor this completely. So this was the pattern that we used the other day, the difference of cubes pattern to factoring. So remember, that's a cubed minus b cubed, and that's a minus b times a squared plus ab plus b squared. So that's how you factor a cubed minus b cubed. So let's do that. So x plus 3 is the same. So let's factor the x cubed minus 1. So that is just x minus 1. And then a squared is this, so that's x squared, plus a times b. So x times 1 is 1x, or just x. And then b squared is just a positive 1. Now this is factored completely. And just as a reminder, like this is already written in the a cubed b cubed pattern because that's x cubed minus 1 cubed, right? So it is already in that pattern. So see if you can go ahead and try these two examples. Show that x minus 2 is a factor, then factor completely, and then show that x minus 6 is a factor, then factor completely. All right, if you try this out, so remember x minus 2, you put the opposite. It is missing a 0x squared, so 1 minus 2, 0, 1, and negative 2. You multiply through, and notice what you'll get is the 1 here, 0, 0, 1, and the remainder should be 0. Then you write x minus 2, that is your first factor, so that you write first. Then you write what's left. This is called the depressed polynomial. So here you write x cubed, and then this is just a 1. So remember, you write it backwards, x to the 0, x to the first, x second, x cubed. And notice it's our sum of cubes pattern, x cubed plus 1. And so that pattern I wrote for you here, a cubed plus b cubed. Remember, that's a plus b times a squared minus ab plus b squared. Then you plug it in, and here it is factored completely. Number 11, this is missing the constant of 0, and you do need to put it in, because if you don't, then you're going to write these numbers incorrectly, right, with the wrong exponents. So if you factor it, you would get 1, 1, 0, 0. The remainder is 0. So this is x to the 0, x to the first, x squared. X minus 6 is a factor, so you write that first. Then you write the rest. So this is x squared plus x. This, remember, you can take the GCF, so you can divide out an x out of it. So when we divide out an x, and I put it in the front, here, divide by x, then that goes here. You're left with an x plus 1, and so now this is factored completely.